Welcome, geometry students, to another Regents review video for the Geometry Common Core Regents exam for New York State. This will be the August 2015 Regents exams. These are the solutions. This is going to be part 1, numbers 1 through 12 of this exam. If you are here to cheat and take my answers and hand them in for homework or something like that, please refrain from using my video. I'll say this every time. The Geometry Regents is really hard and I want you guys to do well. So please do the questions first and then come back to me. Or if you're here because you have questions, you are in the right place. I'm here to help you. So please visit www.nysmathregentsprep.com for more content, video solutions, and a lot more for math. Without further ado, let's get started. Once again, August 2015, questions 1 through 12 for the Geometry Common Core exam for New York State. Without further ado, here we go. Number 1, a parallelogram must be a rectangle when it's... Okay, so these types of questions are really important because it's asking you specifically about a rectangle. Choice 1 says diagonals are perpendicular. That's not even a rectangular property. That's a rhombus. Okay? A rhombus has that property, so that can't be a rectangle. Choice 2 says diagonals are congruent. Yes, that's a rectangle. That's a rectangle. That is specific to the rectangle. We're looking for a rectangle that is specific to the rectangle. Choices 3 and 4, while opposite sides are parallel and opposite sides are congruent in a rectangle, that's too vague. This proves a parallelogram. Now, of course, by definition, a rectangle is a parallelogram, but it's specifically asking you about a rectangle. So choice 2 would be the correct answer. All right, number 2. If triangle A prime, B prime, C prime is the image of triangle ABC, under which transformation will the triangles not be congruent? So we're looking for a transformation that changes size and is not a rigid motion. A reflection. Is that a rigid motion? Does that keep size? Yeah, it does. Translation. Does that keep size and shape and everything else and congruency? Yeah. Dilation. Dilation changes size. So a dilation is not a rigid motion. Now, you need to remember what a rigid motion is. A rigid motion is just a fancy term for preserving distance and congruency. A dilation changes the size because it's being multiplied, or whatever it is, in this case a triangle, it's being multiplied by a scale factor. So it is getting either bigger or smaller. So that's not congruent. A reflection, a translation, and rotation all produce identical copies of the original figure. So for number 2, that's going to be choice 3, a dilation, because it is not a rigid motion. Moving on to number 3. If the rectangle below is continuously rotated about side W, which solid figure is formed? So I'm going to take my highlighter and I'm going to say, all right, I'm rotating around U, side W. So it's spinning around like this. What is this going to create when you spin it? Now, I'm going to sketch the very best to my ability. I'm not an artist, but when you rotate things, you are rotating in a circular manner. So I'm going to create a circular-ish type of rotational thing about side W. Okay, so this is being rotated about side W. Now, what am I creating here, folks? I am creating discs or circles. And this... and it's saying a figure, so which solid figure is formed, that is creating a cylinder. And what I tell my students all the time, this giant rectangle is the revolving door. When you go to I don't know, a department store where they have revolving doors, when you go into a revolving door or the airport, you are pushing against a giant rectangle, and what are you enclosed in? You're enclosed in a cylinder, so that's why it is going to be choice 4. Number 4, which expression is always equivalent to sine of x when 0 is less than x, which is less than 90? This is just one of those facts that you need to know. Sine and cosine are cofunctions. All right, sine and cosine are cofunctions which are complementary. So whatever the x value is for sine, the cosine must be 90 degrees minus whatever that x value is. So that's why it's going to be choice 1, because they're complementary. For example, the sine of 70 degrees is equal to the cosine of 90 degrees minus whatever that angle is. In this case, it's 70. So the sine of 70 is, that looks like a 2, sorry. The sine of 70 is equal to the cosine of 20. And that is just a quick example. And if you don't believe me, type that into your calculator. Is the sine of 70 equal to the cosine of 20? And you will see that it is. All right, number 5. In the diagram below, a square is graphed in the coordinate plane. Then it says a reflection over which line does not carry the square onto itself. I don't like the way that they phrase this question. Basically, it's saying which line is not a line of symmetry. That's basically what they're saying in this question. One of the biggest problems that I see children with or students with that have been going on forever is they are unable to graph vertical lines. X equals 5 is a vertical line passing through all values of x is equal to 5. Okay? So that's the line x is equal to 5. Oops, I'm going to put that in blue. X is equal to 5. Now let's graph all the others. Well, y equals 2, that is a horizontal line passing through all values of y is equal to 2. The line y equals x, that has a y-intercept of 0, and it has a slope of 1 over 1. So that is going to be the line y is equal to x. Okay? And last but not least, x plus y equals 4. That is a y-intercept of positive 4 and a slope of negative 1. That is going to create a line like this. So which of the following lines is not a line of symmetry? Clearly, it's got to be x is equal to 5 because it's not bisected. Well, it's not cutting the square in half. It's not a line of symmetry. Okay? Pretty simple question. Moving on to question number 6. It says, oops, sorry about that. So question 6 says, the image of triangle ABC after a dilation with a scale factor k centered at point A is triangle ADE, as shown on the diagram below. Stop right there. What did I just read? I just said that this is a dilation with a scale factor of k. That means that you should know that a dilation is a similarity transformation. Okay? It doesn't create the same figure. It doesn't create the same identical copy of that figure, but it is a similarity transformation. Now, we could conclude that triangle ABC is similar to triangle ADE by angle. Why? Because angle A is reflexive and angles ACB is congruent to angle E, because I just said that it's a dilation. And remember that dilations preserve angle measure. So all this information should be buzzing around in your head. So dilations preserve angle measure. Now, we need to figure out which of the following is always true. Let's take a look at number 1. It says if I take line segment AB and double it, does that equal AD? Now, you might be prone to think, oh yeah, B is a midpoint. Never said B is a midpoint. That's an assumption. That cannot be true. It could be true, but we don't know the scale factor. Let's take a look at choice 2. It says that AD is perpendicular to DE. It looks like it, certainly does look like that it's a right angle in the picture, but it doesn't say that it's a right angle. So therefore, choice 2 cannot always be true. Number 3, it says that AC is congruent to CE. Many people say, oh yeah, C is a midpoint. No, that's an assumption. It has to be choice 4. BC has to be parallel to DE because dilations preserve angle measure, and I forgot to mention this too, dilations preserve angle measure and they preserve slope. And you should know that same slopes have parallel, or same slopes produce parallel lines. So therefore BC is parallel to DE. That is correct. That's always true. That's the answer for number 6. All right, number 7. A sequence of transformations maps rectangle ABCD onto rectangle A double prime, B double prime, C double prime, D double prime, as shown in the diagram below. Which sequence of transformations maps ABCD onto A prime, B prime, C prime, D prime, and then maps A prime, B prime, C prime, D prime onto A double prime, B double prime, C double prime, D double prime? Oh, that's a lot. So how do we get from here to here? Now, many people look at this and they say, yeah, translation. It's a shift. It's a move. No. Look at the vertices. A is now down here. Huh? What? Yeah, that's a reflection. This is a reflection over the x-axis followed by a rotation. So that's going to be choice 1. Choice 3 was the trick answer. Be very, very careful of those vertices. Number 8, in the diagram of parallelogram Fred, shown below, it says that ED is extended to A and AF is drawn such that AF is congruent to DF. Okay, cool. By the way, this triangle that you see here is isosceles because it has 2 congruent sides. And it says if the measure of angle R is 124, what is the measure of angle AFD? That's up here. We're trying to find that angle. You need to know that in a parallelogram, opposite angles are congruent. So these are just some things to remember. And if you want to jot these down, I encourage you to do so. Things to remember. Opposite angles in a parallelogram are congruent. Now, if that's 124, the angle opposite is 124. Another fact that you need to know, linear pairs are supplementary. And the reason why I'm telling you this is we have to get inside this triangle. This angle next to it is 180 minus 124 because that's a straight line. That's going to produce an answer of 68 degrees. So this angle over here is 68. Now the angle next to it is also 68. Why? It's due to the isosceles triangle theorem. This is an isosceles triangle, and in an isosceles triangle, the base angles are congruent, which are opposite the congruent sides. So this is 68 as well. Now we can solve for this angle with no problem. It's a nice, easy breeze. So it's 68 plus x is equal to 180 degrees. That will give us, let's see. Well, if we take 68 and 68, that's going to be 6, 12, 136 plus x is equal to 180. Subtract the 136 on both sides. Oh, I apologize, folks. That is not 68 degrees. That is my terrible mistake because I go too fast. This angle is 56. My apologies. I sincerely apologize. That's 56. So we have 56 plus x is equal to 180. Again, I apologize. That is going to be 6, 12, 5, 10, 11. That's going to be 112 plus x is equal to 180. Subtract the 112 on both sides, and then you get x is equal to 68, which is going to be choice 3. Okay, that's question number 8. Moving on to number 9. If x squared, completing the square. If x squared plus 4x plus y squared minus 6y minus 12 equals 0 is the equation of the circle, what is the length of the radius? So, x squared plus 4x plus y squared minus 6y. I tell everyone, keep your letters on one side of the equation, numbers on the other side of the equation. So I'm going to move that 12 over, and I'm going to put it over here. Okay? Now we have to complete the square by creating a perfect square trinomial. So what I do is I insert blank spaces after my linear terms in order to create a perfect square trinomial. Now remember, what you do to one side of the equation, you have to do to the other side of the equation. Okay? So to get this in here, you take half the middle term and square it. You take half your linear terms and you square it. Half of 4 is 2. 2 squared is 4. 4 goes over here, and 4 goes over here as well. Half of negative 6 is negative 3. Negative 3 squared is 9, and 9. Now, we don't have to keep going with this because it says, what is the length of the radius? Ladies and gentlemen, these numbers over here, called your constants, this is equal to r squared when you add it all up. 12 plus 4 plus 9 is 25. So r squared is equal to 25. In order to solve for the radius, you take the square root of both sides, and you get r is equal to 5, which is going to be choice 3. Moving on to number 10. Given line MN shown below with M as negative 6, 1 and N as 3, negative 5, what is an equation of the line that passes through the point P, which is 6, 1, and is parallel to line MN? So a couple things that you need to remember for this one too is that parallel lines have the same slope. So if you know that parallel lines have the same slope, you know that the slope of the new line must be the slope of MN. Well, you could actually just read the slope of MN off the graph. Now, granted, could you do the slope formula? Yeah, of course you can. But you could just read it off. Say, all right, that clearly goes down 2 and to the right by 3. Cool. So the slope of MN is equal to down 2 and to the right 3. That's negative 2/3. So therefore, that's the slope of the new line. Now, if you're given a point and you found the slope, you need to find the line that passes through point P. When you were given a slope and a point, you could use the point slope form, which is y minus y1 equals m times x minus x1. Ladies and gentlemen, take this from my personal experience. You have to memorize that formula and you have to know what it does in terms of the problem. If you have intentions to take upper level mathematics, particularly calculus, you are going to be seeing this for the rest of your life. I'm telling you right now. And make sure that you know for the geometry regions because it's going to show up every single time. What I just did is I just took my slope, I plugged it in for m, I took my 6 and 1, I plugged in 6 for x1, and I plugged in 1 for y1. Now we just simplify. Cool. Distribute that negative 2/3, we get y minus 1 is equal to negative 2/3 x plus 2/3 times 6 is going to be, what is that equal to, 4? Yeah. Add the 1 on both sides, and we get y is equal to negative 2/3 x plus 5, which is going to be choice 1. Cool. All right, number 11. Linda is, this is a good one. Linda is designing a circular piece of stained glass with a diameter of 7 inches. She's going to sketch a square inside the circular region. To the nearest tenth of an inch, the largest possible length of the side of the square is what? So first and foremost, I'm going to draw myself a circle. And I'm going to put a square inside. That's what inscribe means, by the way, folks. Inscribe means you're touching all of the points touch the circle at exactly 1 point. That's what inscribe means. Now, they told us that the diameter is 7. Now, if the diameter is 7, I can say, all right, yeah, here to here is 7. But we're trying to find the length of the square. Does that help us anywhere? No. That does not help us. If we say, oh, yeah, that's 7, what else could you do? You can't do anything. It's important to draw this figure correctly. A diameter, by definition, passes through the center and touches the circle at 2 points, and it is the longest chord of the circle. This is also the diameter. If you didn't draw it like that, you didn't know what to do. That's your diameter. And since this is a square, it's a right angle. And this here, this is a right triangle. So if this is a right triangle, we could solve for one of the lengths of the side of the square by using the Pythagorean theorem. Because all sides in a square are congruent, that's x and x, we could use a squared plus b squared is equal to c squared. So we have x squared plus x squared is equal to 7 squared. Remember that your 7 is your hypotenuse because it is across from the right angle. So we combine like terms, your algebra skills have to be rock solid. This gives you 2x squared, not x to the 4th. 2x squared is equal to 49. Divide by 2 on both sides. You get x squared is equal to 49 halves. Take the square root of both sides, and I'm going to type in the square root of 49 halves. By the way, I use the TI Inspire calculator. It is one powerful tool, so make sure that you get it. It's on my website if you need a link. And that gives you 4.94, so that gives you 4.94. Says to the nearest tenth of an inch, that is equal to 4.9. All right, last question. Number 12, in the diagram shown below, AC is tangent to circle O at A and to circle P at C. OP intersects AC at B. OA is 4, AB is 5, and PC is 10. Man, geometry is a lot of words. What is the length of BC? Okay, this is quite interesting. You have to tell yourself that triangle OAB is similar to triangle PCB? Huh? Why are they similar? I'll tell you why. These angles are vertical angles over here. So that's one angle that we could prove. These angles over here are right angles because a radius is perpendicular to its tangent. So these two triangles are similar by angle. This is what the Regents likes to do. They like to give you some background information so you can make the determination on whether or not it's similar. And since these two triangles are similar by angle, we could set the sides in proportion. So I'm going to say, to solve for x, I say, all right, 4 over 5 is equal to 10 over x. Ladies and gentlemen, there are so many different ways that you could set up this proportion. It doesn't have to be like that. As long as you cross multiply and you get the same result, it is correct. So 4 times x is 4x, 5 times 10 is 50. Divide by 4 on both sides, and then you get x is equal to 12.5, which is going to be choice 3. How do we do on the part 1s, questions 1 through 12? That is the conclusion of this multiple choice section. Please subscribe to my YouTube channel and visit my website at www.nysmathregentsprep.com to get more math materials, and you can find answer keys and video solutions and so many more things there on my website, so I encourage you to visit it. All right, I'll see you soon.